Hey, how's it going everyone? It's Lee Halliday, and in this video we are adding a backend to this beautiful map we've built in a past video. The backend we'll be building will live within a Next.js application, and we will use Prisma to connect to our Postgres database. So if we take a look at this beautiful bear sighting map, it allows us to, when we spot a bear, click and add those locations to the map. You can open them and see sort of when this bear was spotted and warn your fellow humans in the wilderness that there's danger nearby. But we had a major, problem you could say, because as soon as you refresh the page, the bear sightings are gone and your friends have some real problems on their hands out there in the forest. So the reason that happened is because there was no backend. We were just storing all of these bear sightings in state. So in memory within the browser, as soon as you refresh, it's gone. So we need to actually store these in some sort of persistent database. So when we think about the backend, we have a number of, choices to make. Just like when you're doing a front end, you could do it in Vue, Angular, React, obviously, like what we're doing here. You can do TypeScript or JavaScript, and there's where you're going to store your state and Redux and MobX. And anyways, there's a tons of questions on the front end, and you have probably just as many questions on the back end. So this is this little chart I put together. So you're working on the back end, which I think is awesome because it's great to strive to be a full stack developer so that when you build this beautiful front end, you can hook it up to something on the back end to persist that data, to send emails, to do all sorts of stuff that you can't really do right in the browser very easily. So you pick your language. You can do it in Node like we're going to do today. But you can use sort of any language on the backend because this is code that runs on somebody else's server, not on your user's browser like you're dealing with in the front end. So you could do Ruby on Rails, you could do Laravel, you could do Django. That's a joke. I don't think you can do COBOL. Maybe you can. I think a lot of the government still runs on COBOL. But once you pick a language, you have to sort of pick a framework for that language to run in. So we're going to be working in Next.js because it's not just a front-end framework. I guess you could say it's full stack. It allows you to add API pages or API routes. But you could do any sort of number of other frameworks that you want to run on the back end, like Nest, Redwood, Express, Adonis, etc. Once you pick your framework, you have to basically decide how the front end is going to communicate with that back end. What sort of API layer in between are they going to use? So you've got your sort of traditional REST, which is where it goes based on the path of the URL. We'll look at this in a little bit. And typically JSON responses are being sent back and forth. You could also use GraphQL and you could use SOAP. That's another joke. Probably want to avoid this. I've had some nightmares over the years dealing with that. So once you know how the front end is going to communicate to the back end, you need to basically choose where your data is going to live. So in your database. And you can choose sort of different types of databases to store your data in a relational style database. So there's Postgres, MySQL. Another joke here, Microsoft Access. Fun fact, Microsoft Access was the first database I ever used about 15 plus years ago with Visual Basic 6. It was pretty awesome back in the day. There's document style databases like Mongo or Dynamo, and there's Graph, Neo4j, dgraph, etc. So we are going to be using a Postgres database on Heroku because Heroku has a free plan, which is pretty cool. Next, how are you going to communicate from your JavaScript code to your database? You need some sort of, I call it ORM, but some sort of query builder, some way for your JavaScript code to communicate with that database. We're going to be using Prisma. It's not exactly an ORM, it's more like a query builder, but it's pretty cool. It allows you to sort of delete data, create data, read data, etc. Finally, when it's ready, and we're not going to touch on it in this video, just because it's going to be pretty long as it is. I'll do a follow-up if people are interested. You need to deploy your code, sort of take it off of your computer running locally and put it out on the internet. Vercel is really awesome for Next.js apps. Heroku is great too. That's where we're using a database. So yeah, let me know if you're interested in that video. And then we add some more complicated backend topics like authentication, scheduled jobs, background jobs, error reporting. We're not going to have time to get into that in this video, but this should give us lots to work with. So this Next.js application that we've got, it's got the map set up and it's time to start adding in those elements to build out a backend. So the first thing we are going to do is set up Prisma. And Prisma, as I mentioned, is the way that your backend code can basically connect to your database. So what we'll do is we'll go down to the command line and we will stop our app from running. We'll just clear that out to make it nice and fresh. And then the first thing we want to do is add this Prisma CLI. And what this will allow us to do, it's a dev dependency. We don't need it when we actually deploy our code. But it will allow us to run Prisma commands to basically generate files and run migrations, etc. So we'll add Prisma CLI, and then as soon as that's done, we will add in the Prisma client. Prisma client. And that one is not the dev one, it's the normal set of dependencies. And with these two in place, we can now run a command. So you can run this a couple ways. You can do yarn run Prisma works, and you would run init. You could also do npx Prisma init. But running this command, what this does is it sets up your, it creates a Prisma folder, and it sets up some initial things needed to connect to your database. So we'll pop back open to the app. Let's close out everything so we've got a fresh start. And right here we've got this Prisma folder. So it gives us a couple things. The first thing it gives us is a .env file. You should not commit this. This is where you're going to put your secrets, your environment variables as you're developing locally. But in here, the key thing is you need to tell it how to connect to the Postgres database or MySQL or whatever database you're using. Prisma supports Postgres, MySQL, SQLite. You need to put in your database connection URL. So at this point, why don't we just pause and we'll hop over to Heroku and we'll spin up a free Postgres database. So come back to the browser. So I already set up a free sort of throwaway account because just for the demo. So this thing doesn't have any servers at all. It's basically just empty. I've got no add-ons, no servers running. They call them dynos. But what we can do is click over to resources, search for Postgres, and we can just add a free hobby database. It allows you to store, I think, something like 10,000 records for free. And if you need more, you can add them. So we could have set up a local Postgres database using like the Postgres app on our Mac or something like that. But this works well because if we were to deploy our code somewhere, this database is already out on the internet and we wouldn't have to do anything else. So if we hop over to settings and we reveal these config vars, this gives us that database URL that we need. So we'll come back and basically just paste this in. And now Prisma knows how to connect to our database. Another file Prisma gives us is this schema.prisma file. And this is where you basically define, well, it defines for you how to connect to your database, what provider, what type of database is it. And this is where we'll define the tables, or in Prisma language, they call them models, where our data will be stored. So that is the next step. What we'll be doing is defining our first model. So the way it works is you say model, and then you give it a name. And then inside you define what types of columns this table is going to have. So model, table are sort of synonymous in Prisma vocabulary. So we're going to give our citing table an ID, which is an integer. And we'll just define a couple things here. We'll say that it's an ID and it has a default value of auto increment. So basically we'll start at 1 and just increment for you as it goes up. Let's add a created at column of type date time, and we want to give it a default of now. so that we don't have to sort of set when this bare sighting has been created. It will just automatically set it to whatever now happens to be. And we want to add latitude, which is a float, and longitude, which is a float as well. So at this point, we've sort of defined our database schema inside of Prisma. And the next step is, how do we take this schema and basically get this table created inside of our actual database? Because right now it just lives in this schema file, so it's not really doing anything. So what we'll do is we'll hop down to the command line again. And last time I ran it with yarn, this time I'll run it with npx. It's running the same thing. So we are going to run npx prisma migrate save. So if you do this, it doesn't let you. It tells you you have to add an experimental flag, and this is because their migration framework is in beta right now, so they want you to be cautious that it's maybe not ready for prime time, but it's pretty cool. So add that flag. And what this does, you have to give it a migration name. So we're going to create a sighting table or model. So when you run that, this is very cool. What it does is it creates you a migrations folder. And it basically takes a look at your schema, how it was and how it is now, and it figures out the difference. And it generates sort of the SQL necessary for your database to get into the state that you want it to be. So inside of migrations, it gives you this README file that basically tells you what it's going to be doing. It was generated by myself at 7:05 in the morning. This is the SQL that's going to be run, and this is the difference between the old schema and what we have right now. And then it's got some internal files that it uses to actually run this migration. So with this in place, we can pop back down to the command line, and we can run, instead of save, we can run up. So what up does is it basically runs any migrations that currently haven't been applied to the database. It applies those. So maybe at this point, what would be cool is to actually peek into the database and see if it's created the table for us. So I'm going to come back and I'm going to copy this same Postgres connection string. I'm going to go into a database client that I have, Table Plus, and I'm going to say new connection from URL. I think it already pasted it in for me, and I'm going to click import. So this will be my Prisma demo, we'll call it. Let's test, make sure it can connect. It's green, so it's all good. So why don't we save that and then connect. Cool. So this is the database. It's got two tables. Migration, you don't have to worry about this. This is something managed by Prisma itself. This is what it uses to know which migrations it's applied or run and which it hasn't. But you can see here we have a sighting table. So this was created based on the schema definition. It's got no data yet, but we can click into the structure and we can see that it's got the columns we defined, the data types, the auto increment, all of that stuff. It adds a primary key, index, all of that good stuff. So this is ready to be used. So what we're going to do now is we're going to start defining our endpoints, our backend code. So we've got our Prisma set up, it's defined our database tables, but now we need to basically, if you've done front-end development, you've connected and you've interacted with different servers via HTTP requests. Now it's time to actually build that part of it. So within Next.js, it all works based off of this pages folder, where you can define different pages, and that's sort of the routing and the URL that it uses. So we were looking at the map here, which is the index, the home page. But if you add an API folder within Next.js, these are basically pages that will only run on the server. They're server side, they're used for sort of building out an API, which I guess, a dumb way of saying this is where you put your API endpoints. So within API, I have a folder called Sightings, and I've already created the 2 files and sort of another one whenever I want to clear out my data as I've been playing around with this. The first one we are going to look at is create. So create is obviously where we are going to receive the data for a bare sighting, and we're going to have to save this to the database. This is the typical structure of a backend API route within Next.js. If you deploy this to Vercel, these all run within serverless functions, but they all sort of follow the same format where you have to export a default asynchronous function that receives 2 things. The first is the request. This is all the information coming through the HTTP request from the browser or wherever it's coming from, and then your response. This is what you're going to respond with back from that request. So why don't we just take a look first at sort of how the data is arriving and how we access it. So what we're going to be doing is we're just going to console.log the request. And a request contains many pieces of information. What the URL is, what query parameters are. But one of the things it receives is a body. Just like that. And we'll save that. So if I hop open to another tool called Insomnia. So I've already been playing around with it here. Let me just clear it out. Okay. So Insomnia is an HTTP client for the Mac that you can basically play around with HTTP requests. For now, we are going to be posting data to our localhost 3000 to API Sightings create. So that was the file that we were looking at. Make sure that the server is running. Perfect. So if I post data to the backend, click send, it's never going to finish because I haven't responded yet at all from the server. But if we come down here, we can see that the body, this little empty brackets, we receive no information. So if we come back here and we send it some information, so why don't we send it sighting? This has to be JSON, so sighting. And we'll send it a latitude of, say, 20 and a longitude of -20. I don't know where that is in the world. Send it again. It won't reply, but we'll come down and we should now have this information in our body because it was posted to this endpoint as JSON. So we come down here and we can see that we have access to the sighting now. So now our job is to basically take this sighting information and save it to the database using Prisma. And then we want to respond to the user that everything was okay, and here's the sighting that we just put into the database. So the first thing we should do, I think, is start to build up what the response looks like to the user. So the way you do that is you can use this response object and we can give it some JSON. So what we can do here is we can say sighting saved. Eventually we'll respond with the actual sighting, but just by adding this little line here, if we come back to Insomnia, we now get a response from the backend. So we're sending the data to this endpoint, and this is what the backend is responding to us as. Server responses, there's 2 main things that they respond with. The first is the status. That basically tells the browser whether things worked or not, whether there was an error, etc. So by default, Next.js responds with a 200, which means okay. And then the response body. So we responded with this JSON here. Okay, we can override the status by calling the status method, and we can respond with 201. So 201 means created. So since we're creating data, that's probably an appropriate one to respond with. But now why don't we get into actually saving this sighting to the database. So the first thing that we'll do is we will create an instance of the Prisma client that I've already imported here. So we'll say const Prisma is equal to new Prisma client. You don't need to tell it how to connect to the database. It already knows via the environment variable that it's looking for. But a couple things we could do is we could tell it basically how to debug. So we're going to debug by putting some information into the logs about our query. Just like that, and that needs to be in an object. And that'll help us figure out what the heck Prisma is actually doing. So now that we have a connection to Prisma, we are going to wrap everything in a try-catch block, which has a finally. So what is finally? Finally happens when try is done or when catch is done. Sort of no matter if it succeeds or fails, it will always run this little block of code at the end. And we'll actually fill in this first. What we want to do is disconnect from our database at the end of the request. And we want to do this to free up connections to our Postgres database, because sometimes there's a limit, and once they get used up, it will start rejecting new connections as they come in. So we can disconnect at the end, and we want to do this whether it fails or succeeds. And we can also deal with what happens if it fails. So maybe we will respond with a status of 500, and we will respond with an error that says, JSON that has error, sorry, unable to save, citing to database. Like that. So try is where the actual sort of meat of this happens, and we want to take the data that came in the body of the request and save that into the database. So the first thing we can do is we can grab the data itself. So that came from the body, and it came in a citing like that. And why don't we actually name the variable citing data rather than citing? So with the citing data, we can now take that data and insert it into Prisma. So we will do const citing equals await, and we'll use Prisma.citing.create. And when you create it, you pass in the data that you want to create. So we want to save the latitude and the longitude. So latitude comes from citing data.latitude, and longitude comes from citing data.longitude. Just like that. So if I save this, it receives the data from the body, it inserts it into the database. As a response, we should get our citing back. So why don't we now respond basically what we were doing down here, which was just for demo purposes. So let's delete that. And we'll come back here and we'll say the response is going to be a status of 201, which means created. And it will respond with JSON with the new citing, just like that. So if I were to come back to my HTTP client and make the same request, now what we get back is the actual citing that was created in our database. You can see that the database automatically gave it an ID of 1. It automatically set when it was created, and it's got the latitude and longitude. So if we come over to our table plus and we refresh this, we can also see that in the database exists this latitude, longitude we created. So why don't we try to send up a null value? Because when I defined the database, I said this column has to have a value. So if we send this, now we get our error back, sorry, unable to save citing to the database. So we're handling errors okay to save some bad data from getting in, and we're saving the good data. So we'll just add like a 25. I have no clue where that is in the world, but so that's saving that here. So the next endpoint we want to worry about, we've saved the data. Why don't we build the index, which allows the user to sort of fetch all of the data? We'll do this one a little bit more quickly since it's very similar to the one we just did. So we want to try, catch, and finally. In finally is where we'll disconnect. What are we disconnecting from? Our Prisma database. So that is equal to new Prisma client. We'll do some logging like we did last time. Query level. So what we can do here is we can try to find the citings. So we'll say const sightings is equal to await Prisma.sighting. And then they've got something called find many, which allows you to query from the database the sightings. And once we have these, that's what we can respond with as our JSON response. So response.json, and we'll set it to, I'm just trying to remember how I want this to arrive to the client. We will do it like sightings. We'll send it down like this. So you don't have to say that the status is 200, but you can if you want to be explicit. We should handle errors, so a status of 500, give the user a friendly message. Error unable to fetch sightings. And then finally, we need to remember to disconnect from our database, so await Prisma.disconnect. Like that. So with our index in place, which is fetching the sightings from the database and returning them as the response, we could go into the browser and we could open up localhost API sightings, and it will query the sightings and it will return them as an array, this is what we're going to be showing within our React app. So with create in place, with our index, our read in place, which will be made as a GET request, we're finally ready to hop back over to React land, and we're going to use React query to read these and to write these back when the user clicks on the map. And this will sort of go full circle and allow us to persist the bear sightings so that we can help protect people out in the wilderness. So we're basically done with the backend. We're going to hop over to React land again. And our goal is basically to replace this state here of sightings. Instead of reading this from memory, we are going to be fetching it from our server. And when you click on the map and it was adding a new sighting to our state, instead of doing this, we instead want to send a post request up to the server to save this information in our database using Prisma. So why don't we get the read working first? And we'll just actually comment out map clicks for now. And so we're going to be deleting this state and replacing it with a request to the server using React query. So I'm going to pop this out. So React query. I have another video which covers some React query in more detail. So we'll go over this fairly quickly and I'll link to that video below so you can access it. So from React query, I have already imported the three things we're going to be using. useQuery, you use this for making GET requests for reading data. So that will be our sightings endpoint to get a list of all the sightings. useMutation, you use this whenever you're changing or mutating data on your server. So in our case, we were posting data for a new sighting, so that's what we'll be using. And query cache, we'll be messing with this a little bit to have optimistic UI updates so that when you add the bear marker, it appears instantly while in the background, it's making the post request to the server. So that's what we're using. So we'll come down here and we'll say useQuery. You have to give it a key. This is what it uses to keep track of some internal cache of sort of what sightings are currently stored inside of its memory. So sightings, and you have to give it a function to basically go and make that fetch request to fetch the sightings from the backend. So we will create a function, and what should we call this? We will call this fetch sightings request, like that. So we'll define this in a second, but what it gives us back is the data, which would be the sightings, and it gives us some other information about an error and about a status, loading status, etc. We're gonna YOLO it and just assume that things are working. You only live once, right? No, really you should deal with that, but for the sake of time, we're just gonna do this. So we're gonna define our async function fetch sightings request up here. And what it will be doing is making a fetch request. So const response is await fetch. Where is it fetching data from? It's fetching from API sightings, just like that. And we'll take our response and we will convert that to the data. So we will await the response.json. And our server responded with data that looked like this, sightings, and it had an array of sightings. So we want to basically grab the sightings and respond. So we'll say, oh, what the heck? Const sightings is equal to data, and then we'll just return our sightings. So with this in place and useQuery from React Query, calling our fetcher function, saving the data into its cache here and returning it here. Let's see if this works. So we'll pop open the map again, refresh the page, and I saved it to 20 minus 20, which is way over here close to Africa. So it's loading our bare sightings from the backend from this endpoint here, and it's now displaying them on our React map rather than reading them just from state. So we're sort of halfway there on the front end. The next thing that we need to implement is how, when the user clicks, to make that post request back and save those in the database. That's what we're going to be working on right now. So to do that, we are going to create a custom hook. And what our hook will respond to us is an array where the first thing in the array is a function we can call to trigger the mutation, to trigger the post request. So we'll call this create sighting. And we'll call the function we are going to create, the hook, use create sighting, like that. So this doesn't exist yet, but we can already start to implement what happens when you click on the map. So when you click on the map, rather than adding the sighting to state, what we want to do is call create sighting, and we want to pass up the new sighting. So we will pass up the latitude, which comes from the event. I have it right here, so I'm sort of cheating. Event dot boom lat long dot lat, like that, and longitude is e dot lat long dot lng, just like that. So with this in place, I can delete this code and it will call create sighting, pass up the latitude and longitude, and it's only up to us now to go and implement this custom hook. So what will this hook do? This hook use create sighting. It's basically just going to be a wrapper around the useMutation hook from React Query. So useMutation, the first thing it wants to receive is what function to call to actually go and make that fetch request back to the server. So this is something that we need to define. So we're going to come up here and define this. So async, and we will call this create async function create sighting request. And let's see if I actually remember how to do a post request with fetch. Probably, maybe not. So what does this receive? It's going to receive sighting data. It's basically whatever, actually not as an object, as a normal. Whatever is passed to create sighting is going to be passed up to this function to actually make the request. So just like up here, we want to say we're going to await fetch to send the data to API sightings create, but we have to send in a bunch of options to override it from making a get request, which it does by default. So we need to tell it to use a method of post. We need to tell it that we're sending the data up as JSON. There's many ways you can post data to the backend. So this is defined inside of the headers that are sent up. Oh, what is this called again? Content type. Content type is application JSON, and we need to tell it what the body of the data is that we're sending up. Because remember, back here on the back end, we grabbed the citing from our request body. So now we're implementing the front end of that, where we are taking this citing data, which is this stuff right here, and we are sending this up, but we have to take this object and JSON.stringify it. So stringify the citing data. Okay, with that done, what we can do is we can convert this into the data. So await response.json. And then we can grab the citing that was created like that, and then we can return it. Okay, so this create citing request is ready. And now we can pass that function to useMutation from React Query, which it will call whenever we call create citing. So I mentioned we wanted to do optimistic UI responses. First things first, why don't we just check to see if this thing is actually working? Because I think at this point it actually would work. So you may have been wondering why when I call my useCreateCiting function or hook, do I have an array coming back where the first thing in here is this function I can call to trigger the mutation? That's because that's what useMutation responds with. If you look at their documentation, it often looks like this. Mutate is equal to this. So what this is responding is an array where the first thing in the array is a function called mutate, but you can call it whatever you want, which triggers off a request to whatever function you passed here to make the actual sort of fetch or HTTP request. So what I've done instead is I've just returned this, which is why I have access to this array here. And instead of calling it generically mutate, I called it create citing. Oh boy, sun is in the eye. All right, anyways, let's see if this works. So refresh the page, click, click. So nothing's happening yet, but if I were to refresh, nothing still happens. So it's time to troubleshoot. What is going on? So when I click here, internal server error. So that's no good. Let's go down here and see what's happening. It's not telling us any information. This is actually good. I have no clue what's wrong. So why don't we come back here and why don't we try to catch and console.error the error, so maybe we can see why this is not working. So Sightings create, that seems right. So let's do that again. Come down here. Cannot read property latitude of undefined. Okay, so that's the issue we have. And I actually do know why that's happening now that I see the actual error. The reason is because when we sent the data up to the server is expecting it to arrive sort of inside of an object that has a citing property, but we didn't send it up. We just sort of said, blah, here's the latitude and longitude as the root level of the object. So we need to come down here, and instead of stringifying it like this, we need to stringify citing like that. So now if I were to refresh the page, let's add some bears near Guelph. We can come down here to network and we can see it's making requests. It's responding correctly. It's not displaying it on the UI yet. That's what we're going to do right now. But if I were to refresh the page, the bears are there. They are being saved to the database. Pop over to the database, refresh. Here's all of our bear sightings being added to the database. Now we are going to, last step is basically add in some customization to useMutation to optimistically refresh the UI as soon as a bear is added. So as soon as the user clicks, the bear is going to appear rather than having to refresh the page or something like that. So the way we do this is we can tie in to useMutation to a few different sort of callbacks, I guess you could say. The first one is onMutate, and this is a function that when it's called basically whenever the mutation is kicked off. So whenever we call create sighting, it's going to send that and call this onMutate callback. And what we're going to receive is the sighting data. And we'll fill in the body of that function in a sec. The next one we're going to do is onError. So this is what will be called sort of if the mutation fails. So here we're given a few different pieces of information, info about the error, the sighting data that was passed to the mutation, and whatever is returned from this onMutate callback function here. So we are going to be returning a function that can be called rollback to basically revert the optimistic UI into whatever state it was before. So if there's an error, we are going to call rollback. Last thing we are going to hook into is onSettled. This is a function that is called basically when the mutation's all finished up successfully. And what we can do, actually settled, I think that's success or failure, but I'm not positive about that. You can check out their docs if you're worried. So what are we going to do onSettled? We are basically going to tell React Query to just go refresh the latest data from the server. So the way we're going to do that is we're going to access the query cache, which is the third thing I imported from React Query. And we'll tell it to invalidate queries, I believe it's called. And which query do we want it to invalidate? We want it to invalidate this Sightings one. So that will basically tell it to go and refresh the data. So the meat of the work we need to do is inside of onMutate, and we need to do 4 steps. So the first thing we need to do, number 1, is we need to cancel any queries that are currently being performed so that this doesn't mess with our optimistic UI refresh. So cancel queries. Number 2 is we want to save a snapshot of whatever is in the query cache that will be used to roll back if there's an error. Number 3 is we want to optimistically update cache so that even though the backend request has not finished, the HTTP request, we can at least show the user what they've clicked and they've added a bear sighting. The last thing is we need to return the rollback function, which resets cache back to snapshot. That's a mouthful. So one thing at a time, let's work on canceling queries. So we cancel queries by saying query cache dot, what is it called? Cancel queries. We want to cancel any queries on the sightings cache key. Next thing we want to do is save a snapshot. So basically figure out what the state looks like right now within the query cache. So we'll call it the snapshot and we'll access the query cache and we'll tell it to get the query data for sightings like that. So optimistically update the cache. So even though the server has not finished, why don't we take this sighting data and insert it sort of temporarily until it invalidates and refreshes the queries here below. And that will give instant feedback to the user. So what we'll do is we'll access the query cache again, and we will call set query data. We're setting it for the sightings key, and we can pass in a function, and our job is basically to return what the state should look like, but we are given the current state prev. We could have also used snapshot here since we just grabbed it, but we don't need to. So what we're going to do is we're going to take the prev, spread that into a new array, and also tack on the information about the sighting that the user just wanted to add. So our sighting expects to have a couple things. It expects to have an ID. Because it's not in the database yet, we need to create a bogus one for a few seconds. So we'll just say new date to ISO string so that we have something sort of unique. It wants to have a created at, so literally the exact same thing to ISO string. And then we'll spread in the sighting data. Cool. So we're optimistically updating our cache with our sighting data. Last thing we needed to do is return a function which will be used as rollback if it fails. And what we wanted to do here is basically take our query cache, set the query data for sightings back to the snapshot. So that is why we saved the snapshot prior to changing the cache right here. Okay. So that was a lot of coding. Why don't we see if it actually works? So I refresh the page, I click somewhere in the forest, and instantly I get feedback that, that the user clicked and this is the data that's been added optimistically. That's not necessarily what is in the database. That's the optimistic one. But when it is finished, it will just go and refresh the latest data from the database. So what you should expect to see if we sort of dive into the network tab is when you click this, it's going to post the data to the server, and then it's going to refetch a GET request, the data from it. So we'll click on the map. So I guess it does one prior to kicking off the mutation. It does one to post the data, and then it does, I know why I did this one prior. React Query has this thing in place for when the window receives focus, it should refetch the data. So as I'm going from the network tools into the map, it views that as window sort of has focus again. That's what this one is. This is my actual mutation. And then this is the onSettled going and refetching the latest data from the server. So this was a big video. We're done, but we accomplished a heck of a lot of code. What we did is we used Prisma to basically define our database schema, what data we want to save and in what format here in our model. We're connecting to our database through this environment variable, which is a Postgres database on Heroku. We created two endpoints, one to create the data that we're receiving and save it into the database. Another one to read all of these sightings from the database using Prisma. And then we went in and we implemented reading and writing data to our backend and eventually the database using React Query. So we created two sort of functions, useQuery, fetch sightings request, which all the way up here, which reads the data using fetch from our backend. And then we created this use create sighting sort of custom hook, which basically hooks into useMutation. It's doing a lot. You may think, is this even worth it? But you're optimistically updating the UI to give the user instant feedback. So I think it's worth the effort for the great user experience. And when this mutation is called via create sighting, when the user clicks on the map, it makes this post request to the backend, which I almost got right first time. It's hard to remember all this junk here, but it posts the data to here with these headers so that the backend knows it's receiving it as JSON. And we passed up the body, which is the new sighting data we wanted to add. So at the end of the day, we've accomplished going from only using state in React to building out a backend using Prisma, Postgres, saving our data so that when the user refreshes the page, the bare sightings are still there and we've saved our friends in the wilderness. Hope you enjoyed this video. Let me know if you'd like to see me deploy this app to Vercel so you could sort of make it live to the world. If you love this and you're still hanging around, please subscribe. I'd love to have you. Take care.